Well, hi, good morning. Thanks so much for joining me here in my shop. We're going to be going the next step with this radio. And last thing I did on it was replace this one capacitor, which had a huge impact on the operation of the radio. So after that, just a short listening test, it seemed to be working pretty good. So I'm certainly not inclined to jump in there and change all those wax capacitors. This is my own personal radio. I own this guy. And I don't even think there would be much advantage necessarily from changing them unless I come up with some observation like what led me to this one. Judging the performance of the radio at this point, it's always a little bit tricky, but just on the little bit of testing I did on the last video, it sure seems to be performing fairly well. So another way we can look at this is there anything that I should do to this radio to maintain its safety? And that's a good question, because this is a I don't want to say hot chassis radio. This one, actually, the chassis, I'm not sure it's actually connected to one of the I'd have to look at the schematic again to be sure, but there certainly is a connection between the B minus terminal, which is, you could consider this to be the B minus terminal, or kind of like a star point here if you like. And there's one connection to the chassis through this big whopping capacitor. So big capacitor, bit of a safety issue. The objective of this capacitor and the 270K resistor that's in parallel with it is to draw down any charges or signals or antenna action that might be going on in the chassis, and force the chassis to be the same potential as the B minus. That's really the best way to put it. If there's no variation in potential between the chassis and the B minus, or if the chassis is forced to be at the B minus voltage, then there won't be any relative signals of any strength pumping in and out of all these parts, because there's stuff happening in the chassis. Because there's nothing happening in the chassis, or very, very little. It would be interesting, hey, here's an interesting test. Let me play this radio, see how it sounds. I will replace this. I'll go ahead and do it. But in the meantime, I'll remove it, and we'll see what happens. Does all kinds of noise show up in the radio? What happens? Now, is there any other connection to the chassis? I don't think there is. I think this is the only way to the chassis is through this capacitor and this resistor, unless there's an accidental contact. So I'm going to eat my words already, because I see a connection to the chassis. Okay, but this is a different kind of connection. So here's a tube connection here. The radio's not on, of course. Here's a tube connection right here. I can see the solder way up in the corner here, just behind the yellow capacitor. So that's pin number 1. So in a lot of metal tubes, pin number 1 is actually attached to the metal shell. So if you hook up to pin number 1 under here, you're hooking up to the metal shell on the outside of the tube. So the outside of the tube metal shell is really something very much like the chassis. So finding it connected to the chassis kind of makes sense. It's just more metal shell, more metal shell. So there's that one. See if there's any other. Those are the 2 output tubes. They're not doing that. So I'm looking for pin number 1. Here's number 1. Yeah, it's soldered. So this one, another metal, and then the last metal is this one. Let's see if I can spot a blob of solder. Here it is. Right here. It's hard to see. It's kind of behind this cover. Right there. Well, while we're talking about this, then, why don't we take a look at the how the tuning capacitor is done. Oh, that's really interesting. There's something surprising there. I hadn't noticed. Flip this like this. Never seen this before. Wow. It's just staring right out. They've mounted the tuning capacitor on a block of wood. I can't say I've ever seen a block of wood sitting in there before. Oops, I'm trying to see if it's loose. Nope, not loose. Well, that's kind of interesting. How exactly did they do that? So I think the purpose of the block of wood is to adjust the height of this. I'm going to guess. That's really what they're up to there. It's not that this is insulating anything. Look at this connection. So on these radios, I often see curious connections that come from inside the radio. They come out through a hole in the chassis, and then the connection, sometimes it's a wire, is soldered to the outside of the plate. Let's look at the other side of this. What is the other side of that? And we'll see how the capacitor is held also. Okay, other side of this. So it's this coil. And I can see a wire coming down from it, meeting here. Now what's that coil? That's pretty certain to be the antenna coil. You can prove it a couple ways. Let's see. So here's the antenna coming in through this capacitor to this coil. So this is the antenna coil. So this must be the oscillator coil. The oscillator coil with a grounded connection. Really? Yeah, I'm going to take a look at the schematic about this. I'm sure I can see a wire coming down there. Let's take a closer look. We'll use the other camera and get a closer look here. So what we want to look at is right down here. So I'm sure you can see it too, eh? The wire just snaking down and going to this terminal. The terminal has a post on it for making a connection. Okay, that's got me stumped. If it was the antenna coil, I wouldn't feel so stumped. Maybe I've got them mixed up. These are fairly large. I don't think so. I don't think so. I think this is a transformer. I don't think this other coil is a transformer. Hard to say just looking at it. How many wires of it? I don't know. What's going on? Okay, let's look at the schematic. We'll sort this out. This is all about just being sure about how the radio is built. Maybe just before we go to the schematic, while I got the camera going here, if you look down under the yellow capacitors to the chassis, you can see. I gotta point to them. You can see these guys here. So it's a screw with a washer through it. A screw with a washer on it, and then a rubber grommet here. And that rubber grommet's keeping the screw and everything from touching the chassis, and it passes right through the radio. It's not a rubber washer. It's a grommet. I don't know if I can see it here. Well, you run into the block of wood, so you can't see what's going on. But see how the block of wood is off the chassis there? It's not actually tight to it. The rubber grommet is under there. So then, how did they ever bolt that capacitor in there? There must just be. Yeah, looks like. Oh. How do you attach one of these capacitors anyway? Well, okay, I'm just a little bit lost as to how this is bolted down. Maybe it must be screws coming up from underneath into threaded. It must be threaded. It must be done that way. Okay. Schematic. So we want to check out this coil and this coil and see what's going on. Okay, let's go. Seen enough. Let us look. Okay, so here we're looking at the schematic. Here's the first coil. I mean, that's clearly a transformer. T1, 2 windings. This shows a metal core. Those lines usually indicate a metal core. See, there's no core shown here or here. These are air core transformers. This one, the output is a metal core, and there's the metal. Why do they do that here? To me, it's very unlikely this would be a metal core transformer. You have here 5 5 F F S S F and F. Side, top, front, second. I don't know what the S is. And look, right to the chassis. Hang on, all kinds of stuff going to the chassis here. So, I've seen this over and over, and I never really studied it that carefully until now. This is the first time I've really studied this carefully. So the chassis is playing a bigger role here than I thought. I'm looking for any other ground symbol. There's one there. So this is the one I found. The connection of the shield, and this one too. So how can this possibly work here? This is the tuning capacitor, and I just showed you it's up on grommets, and here they show it grounded to the chassis. Sometimes in these situations there's a heavy, often braided conductor soldered from the frame of the capacitor to the chassis. Maybe I missed that. So what's the whole idea here? These are all places to sink away the signal. Yeah, this is not going to really come through clearly to me yet, even though I've seen this so many times. My question would be, well, why not just hook all this stuff together and then tie it to the B minus? And why not just bring this to B minus? Why wouldn't you bring this to the B minus? I don't know. Something here I don't understand, but that's okay, because there's all kinds of stuff I don't understand, so who cares? So again, going back to this capacitor that is connected, this one here. So here's the capacitor I'm after, T. M. What's going on here? What's the T for? T dot, T.01, M50. Well, cheapers. T1, T2, T01, T.1, T.2. So a great big capacitor is a 0.2. I think that's what this is telling me. What's the T for? There's a T here. What's going on here? Is there a parts list? No. Is there any? Hey Jim, the T means this? No. Gotta figure it out myself here. Maybe T means tubular, and then S would mean non-tubular. Sure. Here's this S and F thing happening again. S and F. Start and finish. That's what it is. It's start and finish. That's a common way of dealing with coils, is to mark a start and a finish. I guess that helps you keep the phase arrangement correct, so you don't lose track of the phasing of the coil. That's probably where this start and finish thing has come from. Any reason why I wouldn't? Why would it be a concern to operate this radio without that? Without this capacitor and without this resistor, which is really what I'm planning on doing or thinking about. Well, I thought that would leave the chassis floating completely free from the radio, but actually it doesn't. The chassis is still connected to here and here. So everything that's on the grid the grids of this tube. It's coming from a chassis grounded thing. So if I lift this, then the connection of these to the B minus disappears. Now the B minus, so this is a non-polarized plug. Plug it in this way or that way, and there is one wire right here going straight to the chassis. That's what I wanted to spot. Somehow I didn't quite see this. But so in some cases, this line will be at neutral potential relative to your house wiring. And if you plug the plug the other way, this will be at 120 volts. You have 120 volts here. So I think the name of I think I understand it now. I think I understand it. You really want the antenna to work against a ground. The easiest, cheapest, crappiest ground you can get is not really a ground, but just piles of metal. So you want to hook this up to piles of metal. The one pile is the chassis. But if you had the chassis hooked up to the B minus, and you plug this in the wrong way, or a way, you'd have 120 volts right out on the antenna. Be out in your backyard, you'd reach up and grab this antenna while you're standing on the ground with your damp running shoes, and you'll be 6 feet under the ground shortly after that. So how do you get the signals here? Really, it's to reach the B minus, I think, without allowing 120 volts from the B minus to reach the antenna. I think the answer is you do this. So the capacitor is a very large capacitor. So any AC signal of any sort out here is going to reach the B minus, I would think. The purpose of this? I'm sure there are papers written on this. I'm sure if I looked at a little research, I could figure that out. But I suspect it's a backup to the capacitor. I'm not sure. So again, so what happens if I remove this? So if I remove this, then these guys are ungrounded in a sense. They've got nothing. They're working. Well, no, they're still hooked up to the chassis. So we have these guys working on the chassis floating on my bench, all these parts inside that chassis. And the antenna would no longer be working against the B minus. I think you'd lose all the signal. This is like it would be like hooking. It's like trying to run a light bulb from one end of a battery. It's not going to work. You need both ends hooked up. So I think that's the whole serious situation here. How do you manage to build a radio that has no transformer to save the money? Oh, you put all these in series, all the heaters in series. Great. That's one problem solved. But there's a few others, including, well, what do you do now with this B minus thing? Oh, so contain the entire radio inside the chassis, not touching the metal chassis at all. Okay, so how do you handle the antenna then? So you hook the antenna up to the B minus through isolation, an isolation system. Sufficient, so if you are in your backyard holding onto your antenna with your wet running shoes, you don't end up 6 feet under, you just end up dropping the antenna and saying a few explicatives to your neighbor, because there's not enough current to kill you. This is a life-giving circuit here. That's got to be the case. Another way to do this would be to take the antenna, run it through this transformer, pound a ground rod in your backyard, and run this wire out to the ground rod. Now that would probably work, except you need a wire, you need a ground rod, and you need, if you're a man, you need a wife who can tolerate wires running out windows and all kinds of stupid stuff like that. But in the old days, that's what they used to do. This must be a way around that. hey, buy this radio, it will work, you don't need a ground, you don't need to hook it up to your water pipe. Because they've snuck the ground against here, which to some degree attaches it to the entire hydro system. So there's even more metal out there, even if it's onto the live side, the 120 volt side. And then I guess at radio frequency there's all kinds of capacity to earth from the power system in your house and everywhere. So maybe it kind of finds its way to earth through all this stuff. Yeah, I guess that's the story. That's the story I'm telling. I'm telling myself the story. So disconnecting this, I think the radio would just go. It would go. It just wouldn't work. You wouldn't hear much out of it. That wouldn't allow anything. That would mean the voltage of the antenna in that is just undefined. In terms of shock hazard, 120 volts, all that stuff. It's just undefined. It's just a piece of wire. A piece of wire happens to end inside a radio. Well, it would still be connected to the chassis. The chassis has a lot of capacitance against all these parts in here. I mean, it's because of its proximity to all this stuff, it's kind of connected through a fake capacitor, a tiny capacitor, if you like, and a super huge resistor. You could think of it that way. Okay, so that's my theory. Remove these, signal level drops. Radio still works. B minus risk goes up. Shock hazard risk goes up from the chassis. So why would the chassis become a shock hazard? If it's disconnected entirely from the plug, it's safe. I mean, it's just like my chair. My chair over here, I don't have a chair. My chair over here is not plugged in. I'm not worried about it. I can handle it, carry it. What if the chassis was just like that? I think maybe the problem with that is the chassis may not remain like that. At some point, something may touch the chassis inside the radio, and now the chassis is hooked up to whatever it is it touched and has become a shock hazard again. So part of this working then would be, oh my gosh, really? If you had a serious short against this is just like the protection on your hand drill. You get a serious short from the power wires to the frame of your hand drill or the chassis, then enough current should flow in your house wiring system to pop the fuse or the breaker. Is that what this is for? This guy is meant to carry at least, I can't believe it. Like in most houses like mine, I have a 15 amp breaker, and a lot of people think, well, it'll only let 15 amps through. No. That's not the right answer. The right answer is it'll let through whatever is available for some very short period of time. Maybe 4, 5, 6 cycles. This is a fraction of a second. But it could be 100 amps or something like that. Okay, stick 100 amps through something like this, if you could. This wouldn't last long. How could you push 100 amps through that? But could you push 15 is really the question though, because all it needs is 15. So if this restricted the fault current a bit, I still can't imagine 15 amps or something like that. We should grab this capacitor and just shove the leads right into an outlet and see if the lights go out. If we want to prove that. Okay, I just dwelt on this to the point where there's nothing more to see or say. Nothing more to see or say. Okay, I think I'm ready to do some experiments here. I think I have a notion of what might happen. I think I've got enough in my head here. I'm encouraged to move forward. That's a very dangerous situation to be in. Let's go. Don't they call this the Kruger something effect? Which helps us all. The Kruger something effect is the less intelligent you are, the more intelligent you think you are, The more intelligent you are, the less intelligent you know you are. That's kind of how it works. So when we approach something like this big project here, a lot of people, including me, might get cold feet right away. But our tendency as human beings is to not have that happen. Because if that happened, why, we wouldn't do anything. Everything would give us cold feet. And oh, I don't want to try that. So we have to have some daringness in us, and our biology helps us do that by fooling us into thinking we're smarter and better than we are. That's a great state to be in. It could even be to the point where you think you're the smartest guy on the planet. No, that would never happen. Would anybody ever think that? You're the smartest person in the world. Okay, enough of that. So we'll nip these guys out. We'll give this guy a test. We'll run the radio. We'll see how it performs. Poke around a little bit, see what's happened. And then I'll put new ones in and we'll see the result. So first thing is, I better play this radio as it is right now before and get a feel for it. Maybe we'll want to do this with instrumentation. Here's the old cabinet, still waiting for some attention. Let's do this with the a signal generator rather than a radio signal being received. Just because it's going to be a little more consistent and have more control on it. Oh, whoa, that's an interesting question now. So if I'm going to disconnect, okay, the answer's here. Didn't even get the question finished. What am I going to do with this? It's just going to go on the B minus. And then can we get on the antenna here? It's a 50-mile long piece of wire. Comes right to here. Perfect. Excellent. So I can just go right way now. So in hooking up this, I am hooking a hydro system ground from my signal generator onto the radio. Even though the radio is plugged into an isolation transformer, there's a reason why I keep saying isolation joint, but I won't go into it. Isolation transformer, the moment I hook up a ground, there's no isolation anymore. It's all the bottom line of any of this how you run your shop, how you ground things, all that. It's all about knowing what you're doing, and the Kruger whatever effect, thinking you know what you're doing. Well, if you watch any early medical movies or ones that are portraying the way medicine operated, say in the late 1800s, the only reason medicine ever moved forward was because there were crackpot doctors who thought they knew what they were doing as they killed their patients left and right, finding out what they can and can't do. It's kind of a horror story, and we all benefit from it today, but again, the people who are crazy enough to go forward are the people who take us forward. The crazy ones. So I'm just going to nip it off here. We'll leave it in the radio for now. Maybe I'll test it right away. I'll have to nip off the resistor too. We'll do that. So because it's a great big capacitor, I'll leave a little wire there. Okay, if that's off, I'm going to nip open the resistor. Pull this guy out a bit. There he is. Oh, I said I was going to operate the radio before I did that. Yeah, it's because I'm talking away here. It's a very casual thing for me while I'm working in the shop here. This is not a life. I'm not gambling my future or my life on any of this stuff. So I nipped off the capacitor and the resistor here without thinking hard enough about it. So my plan on playing this the way it was is over. We'll have to just remember how it played. It only received 590 poorly. And it would have even been better if I'd redone the alignment on this before doing all this. Oh, well, anyway, lots of afterthoughts. Let's go ahead with this. So we're going to feed in the signal, get this guy operating. Boy, I ever mess up by cutting that thing. I really blew my plan apart here. Let's just check that capacitor for its for its quality. Okay. Because it's a big capacitor, I can run long leads here. Yeah, these leads are capacitors, right? Just really small, lousy capacitors. A few picofarads. So we're going to test this very, very small capacitor. You can't do it with long leads here. You can do it, but you won't get the right reading. So this is just the capacitor being tested. Let me take this off here. Let me do this the other way around, just because for some dumb reason I'd like the black to be on the B minus. Okay. So the objective here is to watch this eye. We're set to 50 volts. Opened up. It opened up fairly slowly, or somewhat slowly, which indicates the capacitor is taking a charge too. Here we go at 150. So that's not too bad. Older capacitors. Not going to be perfect. It's opened 3/4 of the way or so. I'm sure if you go to 250, it's just not going to open now. Oh, it's still opening. It's actually not a very bad capacitor in terms of condition. Give it a moment here to bleed out any charge. This is supposed to be a 0.2. I'm looking at it here. See if I can spot 0.2 on it. Yep, 0.2. Okay. We will measure the capacitance here. So watch for the eye to pop open now. Oh, there it is. It's opening up quite wide. So now, what scale am I on? I'm on the 0.5 to 2 zeros and a 1. I'm on this second scale way over here. So 0.5 is right above my finger there, and so this is measuring like 0.4, 0.3. And my experience with my tester has been pretty good, actually. Pretty accurate. So not quite the capacitance that. Oh wait, it's supposed to be 0.2, and I'm measuring 0.3, 0.4. Well, that makes more sense. The capacitor, I find, when you're testing it, especially in this kind of tester, if it's a little leaky, it keeps showing more and more capacitance. So measuring the capacitance of a leaky capacitor, I think, is not possible. Not accurately, anyway. That's why you see me do the leak test and just forego the capacitance test so often. Not in the worst shape. That's 2 paper capacitors we've tested now. Oddly enough, just to talk about the first one I replaced on the last video had a dramatic effect on the radio, yet tested kind of okay in my tester, which has left me scratching my head. So we're going to operate the radio now without this in. And try to tune to 590, it's just in this area. The antenna that we'll use is this long wire. Just laying on the floor behind me here, and that got us 1 station last time. Maybe we're going to hear all kinds of hums and weirdness in here. Volume down. I don't really know. Don't really know. Here we go. Radio's on. I don't know what I should do about this crazy light bulb. Rig up something with an LED. That's a lot of light it's producing. It needs that much light to just to light this panel up here. Okay, radio's coming on. Sounds like a radio. So you can see what's happening now is, I believe, I'm injecting a signal into the chassis. That signal is going up and down the chassis. It's working its way into the radio somehow through capacitive interactions. coming out the speaker. If I reconnect that, I don't think this would happen. I can prove that by touching the B minus with my finger and not hearing it. Dare we try that? Where's my other hand? In my pocket. B minus. You hear nothing. If this drain was working right on the chassis, touching the chassis, you'd hear nothing. I wish I could just clip it back on and find out. But the radio appears to be working. Sounds kind of normal. Let's see if we can pick up a station here. You know, whoa, jumper. So, I really did make a mistake cutting that out early, because it's really the putting in of the new one which will show the effect of it. The old one's not working 100%. So, clicking it in and out, you're just getting an example of what a not 100% situation is. Great, so I'm going to try to find a 0.2, I'm sure I've got some, and we'll replace this 270 ohm resistor. Why don't we just check it? I would be floored if this is not 270 ohms. Lots of wax on this wire here. Try not to touch the chassis while I'm doing this. I saw 6. 4, 5. Let's take a closer look at that. 4, 5. Oh no, that would be 500K. Probably okay. It's probably okay. Okay, I'll get this guy out and carry on. Okay, so I want to get a more reliable reading on the resistor here, and it's supposed to be 270. It's 290, something like that. That's just fine. And the capacitor here, let me just take a look at it. Wow, that's definitely a big honker. 0.2, made in Canada. Holy jumper. Now what have I got for 0.2? 0.2. We got a 0.25 maybe. What if we try that? That's not a 0.25. That's not a 0.25. This looks more like a 0.25. And always like to double check these because I know myself. It's not that I ever get them wrong, but once in a while they get me wrong. Let's go like that. Oh, I missed. There we are. 0.25, 0.26 in this meter. A little bigger won't hurt. 0.2, 0.25. Look at the difference in the size, eh? Huh. Wow. Now, might be worth knowing which end of this is the outside foil end. They have this hooked up, the outside foil to the B minus. I guess that would make some sense. It may not really matter because it's really because of the job it's doing. I'll try to imitate that. So let's find out which side of this is the outside foil. It's a very simple process. I'm just hooking up the capacitor to the scope leads any which way. There's only two ways. Make the scope sensitive. Hold on to that capacitor. Oh, that line looks pretty straight to me. I see a little bit of a hum dip in it. Now I reverse the leads. Almost no hum dip. A little more hum dip. Again, not much, just a little more. So this way, this lead is the outside foil. Outside foil. Now looking at the wording on here, it's on the far side of the wording. These capacitors are not consistent. And sometimes they're not even consistent across the same size. I have no idea how that could be. Okay, I'm not going to forget. That's enough. How important that is, I don't know. I suppose in very particular circuits, it's actually important. Probably in most, it's not terribly important. And then I need another 270. So I'm going to go ahead and install that. See what happens. Okay, so pretty much 270 on the replacement resistor here. I'm amazed when they come up right on the money like that. I'm just going to, first I'm going to install this against the capacitor. Same sort of thing they did. Okay. We want it to go in with the outside foil this way, and now you can ask yourself, where do you want the long lead? This capacitor barely fit. This one's got lead length. I can have the lead length like this, right? Or I can have it like this, or I can put it in the middle. So where do you want the... Again, I don't think it really matters in this application because it's the chassis that's involved, and it's like, without going into why I'm thinking this, I just think it probably doesn't really matter. So we're going to stick them in like that. Okay. Stick them in there. Okay, we'll just get rid of these excess. Here. That's how I keep these things from flying, by the way. I just put my finger on top. This one's a little awkward. I just hold it. But the little tiny pieces, I put my finger on top so they don't go flying. Works about half the time. Okay. So we're starting today with about, I don't know, close to a foot of snow on the ground. It's going to rain all day. By the end of the day, I'll bet there'll be very little snow left. It's going to rain all night. And then snow. Snow comes again to replace what got washed away. Crazy weather up here. Crazy weather everywhere. It's actually not crazy at all. It's actually all quite normal. Okay. Yeah, normal temperatures here. You know, Canada is a northern country, but and we call the town I live in a town in, well, actually it's called Central Ontario, even though I'm up in the north part of Central Ontario. But if you look on a map where I live, it's actually quite a ways south of an awful lot of the United States. Even though I'm living kind of north here, you know, cottage country, relative to the rest of North America, I'm really not that far north. Good. There we go. Oh, I'm hooking it right up. Okay, so much for my experiments. It's okay. I get lots of good ideas, I never do. I get lots of good ideas, but by the time I get Google up, I can't remember what the idea was. I think that's happening to everybody. Never talked about this. I don't do Facebook and Twitter. Not because I think they wouldn't be fun. They're probably lots of fun. But because I've decided that's something I don't want in my life. I don't want it. So for me, email and texting are more than sufficient for communicating with people. It's another thing. Although you might hear it from me in these videos, because I'm not thinking all that hard, I tend to not share my opinion. At least I try to not share my opinion, but share the facts that I'm basing my opinion on. In conversations with people, I get myself in a lot of trouble because I will raise points to generate conversation that I don't particularly believe in. I just think I'm interested in what the other person has to say about these things. Sometimes when I raise a point like that, people think I'm presenting the point. You know, there's two kinds of conversations in this world. Well, there's more than two. There's a conversation where each side is trying to win something from the other. And then there's a conversation where each side is trying to help the other side with its own journey, with their own journey. If you're trying to win something, then you're offering opinion and all that kind of stuff, and you're arguing. If you're trying to help, your opinion doesn't mean too much. You tend to offer facts and information to help the other person make up their own mind. Okay, while I'm on this topic, if you think that politics is all about trying to find a politician that you can trust, then you're going in the wrong direction. It's not a question of trusting politicians. You know, politicians aren't alone, right? They're inside of a system, and the system is working on them. You watch what's happening in the United States or in Canada right now. The politics are pushing on politicians. They aren't free agents. So there's a big, complicated system there. And I can't even remember why I'm saying this. So I'm going to stop. Okay, let's see what we've done. So the reason I'm doing this is to improve the safety of the radio, because the big capacitor I took out, if it should ever short out, and fat chance it ever would, if it ever did, then as you know, the chassis is connected directly to the power cord, and then the danger level goes way up. So I put in an ordinary capacitor. You know, I could have used an even better or stronger capacitor here, but it's not necessary. Sometimes there's a capacitor right across the power line. Hey, let's look for one like that. If we can find a capacitor right across the power line, we should change that one too. Let's take a look at the schematic. I kind of forgot to look for this. So here's the power line. So let's look at one side. Here's one side of the power line to the B minus. There's going to be a capacitor. It's going to be up in here. Sometimes they put a filtering capacitor literally right across the power line here. But I don't see anything like that in here. It would have to come down to this area here. So I think there is no such capacitor across the power. I wonder if that would somehow snuff out some of the fake grounding I've sort of theorized is going on in these radios, where they're really trying to reach right into the power system. Look, not the third prong ground, just the power wires themselves. I think That's part of what this radio utilizes. So the antenna has something to work against. Okay, that's great. Okay, I think she's ready for a test. Let's put it down. I'll stick this under here. There. Okay, Mr. Radio, how well do you work now? So the antenna remains just a piece of wire on the floor behind me, and everything else is ready to go. Here we go. 110 volts, 112. So the first thing we should see that's different is touching the chassis, which I was just doing, by the way. Should be the same as touching that B minus point. When I touch the B minus point, nothing happened. If I'm going to inject the hum signal into here, nothing, 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 nothing. Good. That's exactly what we expected. Now, how well is the radio working now? Does it sound a little better? Still a one-station radio here. Let me wave that antenna around. Oh. So the automatic light came on in the laundry room next to me, and that's where that static sound has come from. It'll go off in a minute. So like a lot of dimmers, you know, they work by chopping the power. They don't reduce the power going to your light. They chop it. And when they chop it, it creates harmonics because, you know, you can't, you know, the square, you know, all that kind of stuff. There, it just went off. The light just went off. Same thing with switching power supplies. They chop the power and you get harmonics coming out. And even radio signals like are coming out of that one. Terrible, just terrible things. I kind of hung the antenna up behind me here. Hey, where'd the guy go we were listening to? What happened? It's right there. Let me throw my antenna around some more. So I went from having the wire basically suspended through my shop to my door over here, maybe 10 feet, to throwing it on the floor below me, just throwing like that, the spaghetti here. That's the antenna. It worked way better down there. Isn't that weird? You wouldn't think so. Well, I don't think we're going to get any really good. My tripod started falling over. So I think the next thing I got to do the alignment on this next. Then after that, we can judge again whether it's able to receive. It should receive. I mean, decent radio is going to receive 4 or 5 AM signals in here, mostly being done with a loop antenna on the back of these small radios, not with a wire. Oh, a visitor has come. Hello, Shadow. She's going to turn on the light. Go on. There we go. I don't have the radio on there. I thought that would demonstrate quite clearly the effect of having that light come on, but the radio's not on anymore. It is on. Just not turned up. Boy, that's a hum-free radio. I think it's potentially got very good sound too. Alignment next. I'm having too much fun here. Okay, I'll see you on the next video. Thanks a lot for watching this. Even though I kept saying I'm going to do stuff and then don't do it. We got somewhere.